let's get right into this. Welcome to the Ultimate Explainer. Today, we are going to assemble your very own team of cognitive specialists to pull off the absolute perfect answer heist. Picture this. The Cambridge Mathematics exam isn't just a test. No, it is a highly secure, heavily guarded vault. And inside that vault, your top grades, your future opportunities. Today, we are specifically targeting syllabus code 9709. That's AS and A-level mathematics, focusing on kinematics, specifically displacement time and velocity time graphs. But listen closely, because the strategies we are going to break down today apply across the entire board. Whether you're sitting for 0580, 0606, 4024, 4037, or 4040, the security system you're up against is exactly the same. To pull off this heist, we need absolute surgical precision. You know that feeling in the exam hall? The absolute silence, just the scratching of pens, and that relentless clock ticking away? The clock is always ticking. Let me introduce you to two students who are currently failing this heist miserably, setting off every alarm in the building. First up, we have Alex. Alex is a data dumper. He overloads his answers with raw mathematical facts. He practically dumps the entire contents of his calculator memory onto the exam paper with absolutely zero structural analysis. It's just a sea of numbers. Then, sitting right next to him, we have Sam. Sam rushes. Sam is so stressed about the ticking clock that he completely misses the command word requirements in the question. When the paper says show that, Sam just writes a final answer. They are both triggering massive alarms and losing marks left and right. But don't worry, today, right now, we are going to give you the exact blueprint to bypass those alarms, stay perfectly calm, and secure every single mark inside that vault.
Now, I want you to really listen to this quote. This comes directly from a Cambridge senior examiner. They said, most students lose easy marks on kinematics, displacement time and velocity time graphs, but after this explainer, you won't be one of them. That statement should agitate a little bit of fear in you, right? Because nobody wants to throw away easy marks. But it should also bring you a massive wave of relief, because it means the problem is fixable. So why do students like our friends Alex and Sam lose these easy marks in the first place? It's because they approach complex textual questions and graphical data as if they are purely arithmetic problems. They completely ignore the actual story that the data is trying to tell them. When you look at a velocity time graph, it is not just a bunch of random lines plotted on a grid. It is a highly detailed narrative of a physical object's journey through space and time. If you were just blindly guessing your way through a displacement calculation without a concrete strategy, you are literally leaving the vault door wide open for the examiners to deduct your hard-earned points. You're handing them your grade. This explainer is your ultimate, bulletproof strategic solution to stop that bleeding immediately and keep your marks locked down. So what's the plan? How exactly are we getting past the security into the vault? Here is our four-part examiner's blueprint. Number 1, core principles. Number 2, the procedural framework. Number 3, critical analysis. And finally, number 4, examiner warnings. Let's crack this thing open. Section 1, core principles, the theoretical foundations of kinematics.
To bypass the very first layer of security in any Cambridge math exam, you have to realize a fundamental truth. Examiners are actively looking for logical, structured reasoning above absolutely everything else. They want to see how your brain works. This perfectly illustrates the stark difference between an amateur and an absolute master. On the right side, we have superficial breadth. This is our buddy Alex. Alex tries to memorize raw, isolated facts without making any cross-topic connections. Sure, he knows this standard formula for the area of a triangle, but when the exam asks him to find the total distance traveled by analyzing a velocity time graph, he completely freezes up. Why? Because he can't connect the basic geometric shape to the advanced kinematics concept. On the left side, however, we have analytical depth. This is exactly what the Cambridge Assessment Framework heavily prioritizes. It requires logical, structured reasoning and deeply connected conceptual understanding. To achieve this kind of depth, the very top students don't just guess. They decode command words carefully, and they structure their mathematical answers using a specific framework we call PEAL. That stands for Point, Evidence, Explanation, Link. Now, before we break down exactly how to use the PEAL framework to steal those marks, I need you to do something crucial. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, back to the heist. Let's look at how PEAL works for math. Point, the object is decelerating. Evidence, the gradient of the velocity time graph is clearly negative. Explanation, a negative gradient means the rate of change of velocity is decreasing over time. Link, therefore, the acceleration is strictly -2 meters per second squared. Notice how bulletproof that is? There's no room for the examiner to argue. You've locked in the marks.
Let's look exactly at how those top-performing students consistently score higher, paper after paper. I promise you, it is not magic. It's a methodical system. First, they demonstrate absolute mastery of fundamental principles. Second, they show connected conceptual understanding. Third, they apply these concepts to completely unfamiliar contexts. For example, taking a standard textbook displacement time graph and instantly understanding what happens dynamically if the object suddenly experiences wind resistance. Furthermore, they constantly reference cross-topic connections. The principal examiner reports actually state, year after year, that candidates who can fluidly link kinematics to calculus, specifically integration and differentiation, score significantly higher than those who treat them as separate subjects. Okay, let's make this interactive. I'm putting a 30-second timer in your mind right now. Look at these points. Which of these exact examiner expectations directly relates to the Peel framework we just talked about? Think about it. If you guessed utilize precise definitions and causal relationships, you absolutely nailed it. That right there is your explanation and your link. That is how you prove you know your stuff. Moving on to Section 2, Procedural Framework. The technical methodology. This is where we get our hands dirty. All right, if you ever suffer from exam anxiety, pay incredibly close attention, because this is the most important concept in this entire explainer, the method mark strategy. Cambridge uses an assessment principle where marks are rewarded specifically for your mathematical process and your systematic processing. They are not just looking at your final underlined answer at the bottom of the page. Think about how massive this is. If you perfectly set up an equation, but at the very end you mess up a final calculation just because your finger slipped and you typed a 3 instead of a 2 on your calculator, you might lose just one single accuracy mark. But what if you don't show you're working at all? What if you try to do it all in your head? You lose every single method mark. You lose the whole payload. Right now, picture those red pen marks on Sam's rushed, messy exam paper physically transforming into green check marks. Why? Because we forced Sam to stop rushing. We forced Sam to start documenting every single logical step of the journey. How you process the data on the page is just as vital as the final result you arrive at.
So here is your definitive blueprint. This is your 5-step standardized sequence for tackling any kinematics examination question they can throw at you. Step 1, deconstruct the question. What is the command word? Are they asking you to find, show, calculate, or derive? Step 2, extract relevant data. Are we actually looking at a displacement time graph or a velocity time graph? I know it sounds obvious, but getting this wrong under pressure is a fatal mistake. Step 3, select the analytical framework. Do we need to find the gradient of the line, or do we need to calculate the area under the curve? Step 4, execute with clear notation. Use your standard SI units. Make your handwriting legible. Step 5, present with correct terminology. Now, I want you to imagine a 60-second timer ticking down on the screen. Imagine Alex and Sam rewriting their previous flawed answers live right now using this exact sequence. Alex finally stops his chaotic data dumping and starts surgically deconstructing. Sam stops rushing the clock and starts executing with beautiful, clear notation. This specific sequence guarantees that even if you face an impossibly hard, intimidating 8-mark question, you can easily secure 5 or 6 method marks just by setting up the analytical framework correctly before you even solve the final math.
Now, let's really detail the practical application of these skills, because this is where the rubber meets the road. You must be able to confidently extract data from complex text and massive tables. Without getting overwhelmed, you have to actively interpret the hidden relationships between variables. Think about it. If the velocity on a graph is a perfectly horizontal flat line, what does that instantly tell you about the acceleration? It means the acceleration is 0. The object is cruising at a constant speed. You must draw solid, evidence-based conclusions, apply the correct mathematical formats, and evaluate the overall performance of the mathematical model you've built. Mastery of these specific, targeted skills develops a professional-level mathematical evaluation that examiners absolutely love to see. It makes grading your paper a joy for them.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's jump straight into Section 3, Critical Analysis, Evaluation, and Problem Solving.
Let's break down the ultimate deconstruct, solve, evaluate cycle that top-tier examiners expect to see when you are handling high-level problem-solving scenarios. Step 1, identify the given information. Step 2, break the problem down into logical, bite-sized steps. Step 3, solve systematically, line by line. Step 4, check for reasonableness. Step 5, make justified recommendations. Let's do a live interactive workshop right now. Challenge 1, data scan. Imagine I just threw a highly complex kinematics graph on the screen and started a 60-second countdown timer. You're looking at a velocity time graph, and suddenly the plotted line dips below the x-axis. What does that actually mean physically? Most students panic here. They think they calculated something wrong. But using our cycle, you don't panic. Step 1, you identify the information. Velocity is negative. Step 2, you break it into logical steps. A negative velocity simply means the object has reversed its physical direction of travel. Step 3 and 4, you check for reasonableness. If a car drives forward down the street and then throws it in reverse to back up, its total distance traveled is the sum of both those areas, but its final displacement from the starting line is the difference between them. Boom, time's up. You've just expertly extracted the core trend without breaking a sweat.
Let's move to challenge 2. Find the flaw. Listen, true comparative analysis at the Cambridge level requires identifying both similarities and differences, and you must support them with hard evidence and comparative connectives. Suppose we are looking at a sample paragraph written by a stressed-out student. Here's what they wrote. Car A and car B both accelerate. Car A reaches 20 meters per second. Car B reaches 30 meters per second. Okay, 60 seconds on the clock. Can you identify exactly which part of that sentence is hemorrhaging marks? The flaw is that it completely lacks comparative connectives, and it fails to draw an evidence-based conclusion. It's just listing facts. An examiner doesn't want a list, they want an analysis. They want to read this. While both car A and car B experience uniform acceleration, as evidenced by their constant positive gradients, car B has a greater rate of acceleration because its gradient is steeper, reaching a terminal velocity 10 meters per second higher than car A. Do you hear the difference? That is how you forcefully draw conclusions and steal those top-tier marks. And this perfectly brings us to the higher order assessment framework. Think of this as the vault's final laser grid. You have the descriptive level, just stating what's there, then the analytical level, explaining how it works, and finally the evaluative level, where the big points live. Moving from merely describing the graph to fully evaluating it is the master key to unlocking maximum points. Let's tackle challenge 3, speed writing. I'm putting 30 seconds on the mental clock. I want you to imagine writing one perfect Peel paragraph comparing the displacement of two moving particles. Point: particle 1 traveled a further distance. Evidence: the calculated area under its velocity time curve is 50 meters, compared to just 30 meters for particle 2. Explanation: since the area under a velocity time graph mathematically represents the total distance traveled in a given time interval, the physically larger area directly equates to a greater distance covered. Link: therefore, particle 1's overall average speed over the total journey was significantly higher. Time: that right there is evaluative gold. That's a perfect score.
Okay, we've got the loot in the bag, but the alarm is ringing. The guards are coming. It is time for Section 4, Examiner Warnings. These are direct, declassified insights straight from the principal examiner reports. Here are the top 3 critical mistakes, exactly as the senior examiners themselves reported them. If you do these, you drop the bag. Warning 1, forgetting to include proper formatting in your displacement and velocity time graphs. This means totally missing your axis labels, forgetting to write the units, or, incredibly commonly, drawing a wobbly freehand curve when the acceleration is actually constant and it specifically requires a straight line drawn with a ruler. Warning 2, forgetting to check format and presentation. Let's be real, if your working out is scattered all over the page, up the margins, and on the back of the sheet like some chaotic pirate's treasure map, the examiner is absolutely not going to go hunting for your final answer. They will just mark it wrong and move on. Warning 3, answers are not specific to the context given. If the exam question is specifically about a skydiver falling through the sky, do not just write the velocity decreases. You need to write the skydiver heavily decelerates due to the sudden increase in air resistance when opening the parachute canopy. Context is absolutely everything. And that leads us to a massive flashing red examiner alert. I'm quoting directly here. The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. Generic answers are the absolute fastest way to bleed marks. To completely prevent this from happening to you, you must implement a time management matrix. What does that mean? It means you do not spend 10 panicked minutes writing an essay on a simple 2-mark descriptive question, leaving yourself a measly 5 minutes for a massive 8-mark evaluative kinematics problem. A golden rule of thumb? Allocate roughly 1.5 minutes per mark available on the paper. By strictly applying our 3 golden rules, command word decoding, PL framework application, and your time management matrix, you guarantee that every single point you write down is laser-specific, beautifully formatted, and strictly linked to the real-world scenario of the question. Now, before you actually walk into that exam hall on test day, you need a way to permanently anchor these complex terminologies into your brain so they don't vanish the second you sit down. Here is a super quick, highly effective visual memory hack.
Create your own personalized mnemonic for kinematics using the very first letters of key terms. Let me give you a lifesaver. For a velocity time graph, just remember the acronym GAC. That stands for gradient is acceleration, area is displacement, curve means changing acceleration. GAC. Find a phrase or mnemonic that genuinely works for your brain, write it clearly at the very top of your exam paper the literal second the invigilator says you can begin, and use it as your own personal cheat sheet for the rest of the exam. So the heist is complete. The vault is completely empty and you've got everything you need. Here is the final system recap. You must decode those command words, you must rigidly apply the Peel framework to mathematically analyze the data, and you must deploy a strict time management matrix to make sure you never run out of time. Now listen up. Students who actively implement these specific mathematics strategies see an average improvement of 2 entire grade boundaries. But that only happens if they practice consistently with our weekly explainer videos. So here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. I want you to drop a comment below right now with your target grade for mathematics and the single biggest challenge you're currently facing. Our team reads and responds to every single comment. Like and share this explainer with a study partner who needs to pull off this heist with you. Ace the Exams. Your Cambridge success starts here. So, the final question remains. Will you rely on generic answers and scattered calculations like Alex and Sam used to, or will you boldly use the examiner's blueprint to systematically secure every single method mark on your next kinematics paper? The strategy is entirely in your hands. The examiners have literally handed you the map to the vault. The only question is, are you disciplined enough to follow it? See you next time.